Hey, my name is Kieran Timmins, and my project was biocontrol of the invasive Japanese beetle using a native Microsporidian. I worked with Vera Krishik and Simran Rana on this project. The Japanese beetle is an invasive pest from Japan that feeds on over 300 species of plants, causing problems for property owners and wildlife. Ovovesicula is a Microsporidian that's under study as a potential biological control agent of the Japanese beetle. Biological control is when you use something that already exists in nature that controls a population or could be used to control a population, and you try to spread it around so it prevents an invasive species from taking over. So, for instance, in this case, we're using the Microsporidian ovovesicula to infect Japanese beetles, increasing its mortality and decreasing its fertility, causing it to die out in the US would be the goal. But right now, there is no effective way to disperse ovovesicula among JV populations. However, previous research at our lab saw that cellulose mixed with ovovesicula spread on leaves caused Japanese beetles to eat more of those leaves when compared to other treatments, which means that ovovesicula and cellulose could be a potential way to spread the spore around the country. So within this experiment, we collected 54 grubs from around the U of M campus, digging 3-inch holes in mulch, and then bringing them back to the freezer and storing them. So the master mix we used to put spores into our treatments is a master mix provided to us by Michigan State University, which is just a concoction of dead beetles, and this was our stock solution. We created 3 treatments of vesicular cellulose, which was a mix of our master mix, water and cellulose, ovovesicular water, which was just spores, which is our master mix, and water, and water, which was our control. And that was just water. So no spores were in that one. Our treatments, we mixed in an Erlenmeyer flask with a stir bar for 60 seconds. And we had 6 petri dishes per treatment, 3 beetles per dish. And then we used 2 milliliters of our treatments and put it over the top of the grubs we used. And then we let them sit for 30 minutes. And then we rinsed them with water to see what kinds of spores or like if how many spores would come off in the rinsate. And then this was analyzed using a hemocytometer in a microscope. And so we saw that ovovesicular and cellulose had an average of 5,416 spores in the rinsate, whereas water had a little over 800, or no, water and ovovesicula had a little over 800, and water itself had 0, meaning that cellulose and ovovesicula had the most spores in the rinsate. And we found this with high statistical significance, both when comparing treatments across treatments and within treatments, and when comparing the treatments of the rinsate to the original stock treatments we created. So we couldn't maintain complete, like the spores in each treatment wouldn't be the same. So I counted the treatments themselves and the rinsate, and then we compared that, and that had even higher statistical significance with an F ratio of 40.6 and a p-value of 0.0001. So, as I stated earlier, previous experiments showed that when leaves were covered in ovovesicula and cellulose, that Japanese beetles ate more of it. So we thought it would be a good way to spread it around. But in this experiment, it was shown that ovovesicular cellulose did not stick to the Japanese beetle grub bodies, which would be a way to hopefully infect them. Instead, it was washed off, probably with the cellulose, because the cellulose has a sticking capacity, and we see that we found even more ovovesicula in the cellulose treatments, meaning the cellulose had some effect, and we think that is with its sticking capacity. And it carried the ovovesicula off, and we found more in the rinsate. So it's possible that given more time to dry onto the beetles or sit, we could allow more spores to stay on the beetles, potentially causing more infection. So in the future, we'd like to test different dilutions of ovovesicular cellulose, see if what dilution would give us the most spores in the beetle, try varying amounts of time. Like I said, give it more time to dry onto the beetle. We could potentially keep more spores on the beetle. Use adults in addition to grubs, because we want to infect adults and grubs to see what's the best. Grass roots and linden leaves, because that's what adults and grubs eat. Grubs eating grass roots and adults eating linden leaves. So if we could put it on their food, that could be potentially a way to infect them. And so, in conclusion, Japanese beetles are a pest. Oviosicula is used to control them, and there's not really a good way to spread oviosicula right now. But seeing as we found like a high statistical significance, and we saw that Oviosicula cellulose had the highest amount of spores in the rinse site. Hypothetically, if we could cause Oviosicula and cellulose to stay on the beetles if given more time, we could apply this to grasses, we could apply this to linden leaves, and potentially use it as a way to spread Oviosicula around the US and wherever else the Japanese beetle is invasive. So our results suggest that there definitely is some binding properties, and we would be able to use it in the future. So my name is Kieran Timmins. This is my project. Thank you so much for listening.